This is Banky here. Just going to talk a little bit about the periodic table and a little bit on the history of the periodic table. So the person to get the credit for putting the periodic table together was a Russian scientist by the name of Mendeleev. And here are some pictures of him when he was younger and then a little bit older. You can see his hair got grayer and his beard got longer, but he hasn't really changed much. So this is an example of the very first periodic table that he put together. So what I would like you to do right now is just pause this and just spend some time looking at how this periodic table is the same and how it's different than the one that we're familiar with. So go ahead and pause this and then make some observations. Okay, I'm sure you're done making your observations right now if you've resumed the video. So there are a couple of things that I want to point out. He arranged his table by atomic mass, and that's what these numbers mean. This is in a different language, it looks like German, but these numbers represent atomic mass, and the columns represent periods on our periodic table. So going from beryllium to boron to carbon to nitrogen to oxygen to fluorine. So that's how our periodic table goes across a period like this. And the rows are aligned according to similar properties. So Mendeleev noticed that fluorine, chlorine, bromine, and this element here, I'm not sure why it's a J, but it represents iodine, all had very similar properties, as did sodium, potassium, rubidium, cesium. He noticed some similar properties with that, and lithium. So there are some question marks, things that he's unsure of. For example, he arranged this according to mass, and here is one spot where it seems to go out of order. We go from 122 to 128 down to 127, and this element here just didn't fit in this spot, so he did align it with the other elements that are similar to it. You can see not all of the elements are here, and there are some elements where there are just question marks. So he went as far as to predict the properties of elements that hadn't been discovered yet, and he had full confidence that they would become discovered and they would have similar properties according to his predictions. This is another very, very blurry video. This time iodine does have an I instead of a J, showing how this does go out of order with the mass, but he still aligned this and put this in that place because of its properties and its similarity to the other. These are the group 17 elements. So his first periodic table, what I asked you to do while pausing it was to compare this arrangement with that of the modern day periodic table and look at how it was arranged. And as we just discussed, he did arrange according to atomic mass, and he also arranged according to atomic properties. So he did notice similarities in chemical properties and that they occurred at regular intervals. And when you have repeating patterns, it's referred to periodic or periodicity. He published his first periodic table in 1869. And one of the problems is that his procedure did leave many gaps. And again, he had the confidence to actually predict properties for elements that hadn't even been discovered yet. And part of his fame and recognition came from these predictions and how close they actually were. With the publishing of his first periodic table, he earned credit as the discoverer of the periodic law. A later definition for periodic law comes about that was developed by a guy by the name of Moseley, but Mendeleev is given the credit as the discoverer of the periodic law. With the arrangement of the periodic table, it didn't really explain why some of the elements didn't fit the atomic mass trend, and it doesn't really explain why these repeating patterns even exist at all. So in this slide, you can see that these were the predicted elements, and he called gallium eka aluminum, and I think eka means on top of or beneath. So I'm just going to go to this one. Aluminum is here, and the eka aluminum would be right here. So it looks like aluminum is on top of the aluminum. I know in this image it's side by side, but remember this is similar to a group on our periodic table going from the boron to the aluminum in group 13 or group 3A. So eka aluminum was the one found on top of the aluminum, and his predicted properties would that it would have a density of 6.0. The actual property is 5.96. Incredible. Not even knowing of this element existing, predicting these products. He determined it would have a low melting point, and it's low enough to melt in one's hand. Two other elements, scandium and germanium, were predicted. The properties were predicted, and you could see very similar properties in what was actually observed and what was predicted. So this is one of the things that made Mendeleev most famous and really most noteworthy in terms of his insightfulness and his ability to take patterns and take evidence and actually predict the properties of these undiscovered elements and do a really good job at it. So a little bit later, Moseley discovered that when protons were discovered, he recognized that elements did fit better in better patterns when you arranged them by atomic number. So when you do arrange by atomic number, that iodine does fit right in place on top of the other group 17 elements, the bromine and the chlorine and the fluorine. And the periodic law is that physical and chemical properties of elements are periodic functions of their atomic numbers. So the periodic table is arranged according to the number of protons, or the atomic number of each of the elements, and the trends that we see are best seen when the periodic table is arranged that way. So the modern periodic table is a little bit different than what it was during Mendeleev's time. We have since discovered other elements. There have been many changes since 1869. And by definition, the periodic table is an arrangement of elements in order of their atomic numbers, so that elements with similar properties fall into the same column or group. A discovery that occurred much later were the noble gases. And helium and radon and neon. Oh, excuse me, I have a big yawn. Those noble gases were discovered later because of their unreactivity. They didn't combine with compounds, so they really just didn't really stand out. And they were discovered in a variety of different ways. Lanthanides and actinides, many of them had been known at the time of his periodic table. They were a puzzling group of elements. They're both set apart from the periodic table, and you can see that on the periodic table, lanthanides and actinides are located down at the bottom. So that's another group that was added after Mendeleev's time. And one thing that you can notice again on the periodic table is repeating patterns. If you look at elements down a group, whether it's group 18 or group 1, and you look at the difference in atomic number from the first element to the second is 8. And the same goes here. From the second to the third, the difference is 8. From the third to the fourth, the difference is 18. And then the same pattern can be seen as you go down the group. So that was one of the atomic trends, or the periodic trends that could be seen. So periodicity can be observed with respect to atomic numbers. Patterns are seen repeating with respect to atomic numbers. So here are some section review questions, and I would like you to just pause this and go ahead and try answering these questions. And then you can start it back up and I'll go through the answers pretty quick here. Well, as soon as you're done. Okay, if you've paused it and you're coming back now, we can go through the answers to these questions. Who is credited with discovering the periodic law? Even though the periodic law involves the fact that the periodic table is a function of the atomic number, the periodic law, if we go back and look at that periodic law again, that physical and chemical properties of elements are periodic functions of their atomic numbers. Even though this periodic law wasn't defined as it is seen today until Moseley gave it that definition, Mendeleev was credited with discovering periodic law. And who established atomic numbers as the basis for organizing the periodic table? And that was Mr. Moseley. And the periodic law, I just went back to. Name 3 sets of elements added to the periodic table after Mendeleev's time, and that includes the noble gases, the lanthanides, and the actinides. So, a little introduction to the periodic table, how it was arranged when Mendeleev first put it together, what elements have been added since then, and how our updated modern approach to it really isn't that different than what Mendeleev did, but just a little bit fine-tuned with the introduction of the proton and organizing according to the atomic number. So that's all for this one today.